Chapter 7, Exercise 7.77, Part A. The combustion of gasoline produces carbon dioxide and water. Assume gasoline to be pure octane. Carbon 8, hydrogen 18, and calculate the mass of carbon dioxide that's added to the atmosphere per 11.2 kilogram of octane burned. Hint: begin by writing a balanced equation for the combustion. So first, we'll balance the equation. Honestly, we don't have to do that because 1 mole octane produces 8 moles of CO2. That's all we need, right? So 1 mole of carbon 8, hydrogen 18 reacts with oxygen to produce 8 moles of CO2, just to balance the number of carbon atoms. All right, so really it's okay. I'll show you how to work on this really quickly. So it's going to be 11.2 divided by 8 carbon and 18 hydrogen. That's the number of moles of C8H18. And then times 8 times the mass of CO2. CO2, there's 1 carbon to oxygen. All right, so that's it. Again, we don't have to balance the combustion reaction because we know there's a 1 to 8 ratio between the number of moles of octane and the number of moles of CO2. That's it. This is the molar mass of CO2. This is the molar mass of octane. Alright, so yeah, we got the correct answer by entering the proper expression. What is the balance equation? It's this, but I'll show you how to balance this from scratch fairly quickly. I just need some space over here. We have carbon 8H18, we have oxygen, and we get CO2, and we get water. Alright, you do need to know the products are CO2 and water. Alright, typically. If you don't have enough oxygen, you get carbon monoxide. I look at this equation, I find the most complex chemical and put 1 in front of it. Alright, temporarily. And then I have 8 carbon atoms on the left, right, in total. I'm sure about that. 8 carbon atoms. So this has to be 8, right? And I know there are 18 hydrogen atoms on the left, so it's this gotta be 9. 9 times 2, 18. I have only 1 more coefficient to decide. There are 16 oxygen atoms here, 9 oxygen atoms there, so 16 plus 9, 25. Here we need 25 oxygen atoms, so 25 divided by 2. Now we have this chemical equation balanced. Somehow mastering chemistry does not allow fractions as coefficients, so we'll just multiply every coefficient by 2. This will become 2, this will become 25, this will become 16, and this will become 18, and then that's it. So you got this equation, 2, 25, 16, 18, that's it. And you can double check the number of carbon atoms, hydrogen atoms, and oxygen atoms. But anyway, you don't have to balance this chemical equation as long as you know 1 mole octane produces 8 moles of CO2. The ratio is 1 to 8, and you'll get the answer correctly.